Hey guys, in this video we are going to see how to prove the formula for inverse of a 2 by 2 matrix. So let's write down how a 2 by 2 matrix can look like. I have these, think of this as for different constants. It's A, B, C because it's easy. So the actual definition of the inverse of a matrix is you need to multiply this by a matrix. So remember, matrix multiplication is only possible when this of course has 2 2, so this right here must be 2, and the definition states you should get an identity matrix when you multiply the original matrix with another matrix, which is of course the inverse. So here we are trying to find what is this matrix right here. There are 4, 1, 2, 3, 4. I mean the values. This should be a 2 by 2 because this identity matrix right here is 2 by 2. So here we have 2. These two must be same for the multiplication to be defined. And here we have a 2. And here we have a 2. So this 2 corresponds to this 2. So this 2 corresponds here. So this is 2 by 2. So there are 4 values we should find. These 4 question marks, I don't know if they are perfect. Maybe. But just to get an idea, we need to find 4 values so that we get an identity matrix when we multiply. And the inverse varies with the matrix, whatever. Like if you have this matrix, it has a different inverse than this matrix. And sign matters too. Like if you have negative, it still matters. So let's see how we can prove. So this is the formula for inverse of a matrix given the matrix ABCD. We're going to prove this over the span of video. Let's see how I can do that. Here we have our original matrix and this is the identity matrix. So we need to find this matrix right here. So I just gave some random names, PQ or S, for the 4 values inside the matrix. So how matrix multiplication goes? AP plus or P or whatever, you can call it anything you want, is equals to 1. See the first variable over there. Next we have this AQ plus BS is equals to 0. Next, CP plus DR is equals to 0. Then we got, what did we get? DQ, right? DQ. No. So DQ, it's CQ. This really matters. So first let's find a relationship between P and anything. Let's just find a relationship first. So we have these 4 equations and these are important, really important. These are the only data we have, like seriously, only data we have. So this is going to be very important. Let's clear some space for ourselves. This doesn't have any space. I need to make a new slide. Now we got the system of equations. Let's solve for individual stuff. So here we got PRs. Remember, we are solving for this matrix right here, but not this matrix, because these values are already fine. Because if without knowing the matrix for which you need to find inverse, you can't find the inverse. So don't think about these matrix while you're finding. it seems like in the problem there are like a lot of variables, but still. So first we have this system of linear equations right here. Let me zoom out. So let's write down like on this side. So we got, so when you first learn the process of elimination, I don't really remember the name, it says you need to, whichever term you want to like take out, like you don't no more want to state in the equation, you just multiply those coefficients, I mean the LCM. So here I want to take out P. So the common LCM, least multiple, is AC. So let's multiply this equation right here by C to get AC. ACP plus BC R is equals to, do we get C? Just C, because it's 1 times C. And the other side is the same way, we multiply A this time though. Here we get AD R is equals to, and A times 0, 0. So when just subtract these two, you end up with these to cancel that. Here you can take out BC minus AD common, and we got R. Ooh, look at that. Here most of these are already constants. R equals to C over BC minus AD. And this we can also write as negative C over BC, I mean AD minus BC. Pretty cool, right? We just found the value of R in terms of all constants, because as I said, these terms are already given by the thing is giving the problem. So you don't need to really care about that part. So let's erase this stuff, or let them be. So I need to clear this place, it's really messed up. So let me make a new slide again. Now we know the value of R, negative C or AD minus BC. You can now find the value of course P. Just substitute in the 0 one, because 0 you can make nice equalities, or equalities too. So just substitute the value, nothing you need to do, and just say CP equals to negative DR, which is negative, the D is just D, but here we have negative C, AD minus BC, right? Am I right? Yes, you are. So you can just cancel the C's out here, and then the negatives. Middle of it, P is equals to T over AD minus BC. Pretty cool, right? I think you're kind of observing the pattern of this AD minus BC in the every solutions, like AD minus BC, and you're going to observe the same pattern in the next two, which is these two set of equations right here. You're going to see that in those two, and that's why we actually had a thing, scalar quantity pulled out, so it makes it easier inside, and you can just multiply all those by once. We'll see. Trust me, you will see. So now we have just these parts left here. Just solve it in a similar way. Find a common thing. Of course, AC again. A is a Q, and then BCS is equals 0. Then ACQ blah 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 blah. ACQ plus here AD. As we got A, I guess, right? Yeah. Just again the same blah blah. Let's try it in a different way. Like we are dividing, subtracting this from this. So these two get cancelled, but it would be AD minus BC, not BC minus A. Doesn't make any difference though. A minus 0, which is A. We simply got S equals to A over AD minus BC. Ooh, same AD minus BC pattern. Oh, really? What is that noise? Okay, wait. I just got super excited. So remember that I'm erasing it. Anyway, you can just rewind the video, of course. I can't do that though. Well, when I'm watching my own video, I can. So we now know S. What is S? Dang, I just forgot. No? Yes, maybe. We'll find out. And simply just AQ equals negative BS. We need just to find Q is equals to negative BS or A. Negative B, which is just leave it as it is. As we just said, A over AD minus BC times A. See, we have A in the denominator. Never forget that. So we're left with I need some space really. Left with this. Sweet guys, really sweet. Now let us write all these in like one big page. All the values we found until now of P, Q, or S, which are the, of course, the. Dang, I just forgot. Seriously, what did I just do? P, oh no, P, Q, R, S. P is equals to neg D over 80 minus BC. S equals to. I just remember this way because it's quite easier than you think it is. Negative B 80 minus BC 80 minus BC. So now let's write this in the form of a matrix. How? You know how? I need to write it real quick. I'm just tired. We have D over 80 minus BC. A over 80 minus BC. Negative B over 80 minus BC. It is C over 80 minus BC. What can we pull out? Of course, this is a scalar. Remember, scalars can be pulled out. Look at that. Look at us. Sweet. We just proved how we can actually find the inverse of a cool 2 by 2 matrix. I'm pretty damn sure use the same method for the inverse of a 3 or 3 matrix, which it is harder to solve 3 by 3 equations, but it will still be this way. Trust me, it's easy. See you guys in the next video. I'm hopefully not going to prove the 3 by 3 inverse because it would take so long and long time as well. A lot of effort. There's a lot of equations. It's just messy. You can search for internet, but it doesn't make sense to do so because you never use 3 by 2 matrix in real life. Computers use them. Okay, bye for now.